warm up for today. Um, Started off fairly simple. I was trying to establish the connection between the whole number division work that we've been doing, and the division as we will see it in fractions. So here's a simple problem. 6 divided by 2 is 3. And I wanted to make the point that you could also think of this as a fractional notation, where this denominator says I need 2 items to make an entire object, and I have 6. So think about that for a minute. If it takes 2 items to make an entire object, and you have 6 items, then altogether you must have a total of 3 items. And without belaboring that too much, if it takes 2 items to make the entire object, it takes 2 items to make the entire object, 2 items to make the entire object. I'm getting sloppy here. And you happen to have 6 of those items, so you have 3. Now, on the other hand, if you think of this, if it takes 6 items to make the entire object and you only have 2, then obviously you do not have a complete object, right? You've got a part of an object. So again, in this case, it takes 6 items to make the entire object, and you only have 2 of them. And if we tried to draw that, we would have a single object that requires 6 items to make it complete. Is that 6? 1, yeah, 6. Excuse me. And what do you have? You happen to have 2 items. So you can tell in this case, you've got 2 out of 6, and you can simplify that, and I'm going to talk about that in a second over here. You can simplify that to an equivalent fraction of 1/3. Then we said, hey, what about dividing when you have a fraction? Well, the idea with dividing in fractions is you have to remember that sometimes the results you're going to get are going to look a little strange. And the technique is to use multiplication to accomplish the division. And we say 6 divided by 1/2. And then we do the keep, change, flip, change to multiplication, and flip the divisor. And why does that work? Well, if you think of this as being written as 6 divided by 1/2, and you say, if I could turn this into 1, I would have a number over 1, which is equal to the answer, or a number. So how can I turn this bottom into 1? Multiplied by its reciprocal. And to maintain an equivalent fraction, I've got to multiply in the numerator as well. So you go through that and you find that you get 12. And so that's what we got as an answer. Now, what in the world does this mean? Well, think for a minute. I have six entire objects, and I want to determine how many groups of 1/2 can I make if I have 6 entire objects. And so try to do to show this down at the very bottom here. So we said 6 divided by 2 was 3, and they said, wait a minute, now 6 divided by 1/2 is 12. So I simply said, okay, I have these 6 objects that I was going to put into 2 groups, and I got 3 groups of 2, which was the first problem up there. And then I said, well, what if we said 6 divided by 1/2? Well, I said these 6 items, I just divide each of them in half with a little red line. And so what do you have here? You have 2, 4, 6, 8, 10, 12. So I had 6 entire objects and divided each one of them into a group of 1/2, and so I wound up getting 12. Now, this one says a little different. This one says 1/2 divided by 6. Now, you immediately know that you can't form a group of 6 if you only have 1/2. So what is this asking? It's asking me to say if I had a half of an item and I wanted to divide it up into 6 equal sized pieces, what would I get? Well, I would get 1/12. And you can come back to that answer by simply saying, well, if I had 6 of these, 6/12, put the 6 here. If you had 6 of these, 6/12 would reduce to 1/2. And again, we did the keep, change, flip. Here's a straight multiplication problem, and when you're multiplying, you just multiply straight across, and you put a 1 under this whole number so it's clear to you that you're multiplying 6 times 1 and 1 times 2, and then there's your 6 divided by 2 problem, which we've had that a couple of times already. Half times 6, same thing. Put a 1 under the 6. Half times 6 is 3. Now, the other thing I want to point out is this is saying repeated multiplication. When this multiplier, the first number is a whole number, you're saying I have 6 of these 1/2. And so here we go. Here's 6 1/2 down here. So 6 1/2 would be, takes a half plus a half is 1, half plus a half is 1, and so forth. So I think you can see that 6 1/2, if you added them together, you would get 3. Now, on the other hand, this is simply saying, look, I'm going to take a part of 6. So when the fraction is the multiplier, remember the first digit, so first value is a multiplier and the second is a multiplicand. When this is the multiplier is a fraction, you're saying, hey, I'm taking a part of something. What are you doing? I'm taking part of 6. How much are you taking of 6? I'm taking half of 6. And so you get 6 divided by 2, and you get 3. Now we also did a little fraction, did a little ruler work here. And so I surely hope that you will come. I'm trying to slide this around where I can fit my ruler in with the camera. I hope that you will use this as an opportunity to master a little ruler measurement. So what did you get there? What do you think that is? 3 1/4. What about this one? 4 3/4. And then the last one, no, that was 4 3/4. 3 1/4. Oh, and here's the other one up here we did. Let's see if we can pick it on. So what is that? Well, it's a little more than 2, right? 2 1/8. So please practice your ruler skills, because this is a great visual on fractions. Each of these spaces between these whole inch units here can be thought of as a fraction. So you can really learn some fractions by using a ruler. Now, the last thing we talked about a little bit was this whole idea of, if I want to add 2 fractions together, I can't add them unless I have a common denominator or an equal denominator. So if you had a fraction like 7 over 24 added to 5 over 36, these are obviously different size pieces, meaning, hey, one object was cut into 24 pieces and I got 7 of them. Another object was cut into 36 pieces and I got 5 of them. Oh, by the way, these were the same object. They were just sliced up differently. And I wonder, how many pieces do I have all together? Well, to do this, you've got to convert them to the same size piece, so you know you're adding pieces to pieces that are consistent. To do that, you've got to find a common denominator. And how do you do that? Well, you use the lowest common multiple. And there's 2 ways to find the lowest common multiple. Make yourself a table of multiples, 24 and 36, and multiply by whole numbers. And find the first place that you find the same result. And in this case, it's 72. So therefore, hey, I've got to turn that into 72 and that into 72. How do I get that to 72? Multiply it times 3. How do I get this one to 72? Multiply it times 2. So here's your lowest common multiple in that table, right? Now the other way to do it is to factor. So you look at this factorization and you say, here is 24, here is 36. So to find the lowest common multiple, the lowest common denominator, what you do is you bring down each of the individual factorizations, the greatest number of times it occurs in any one of the factorizations. So 2 occurs here 3 times, 2 times here, but we'll pick it up 3 times. 3 occurs twice here, and once here, we're going to pick it up twice. You put all that together, and you're going to get 72. 2 times 2 is 4, times 2 is 8, times 3 is 24, times 3 is 72. So you can either do the factorization technique, which will find your lowest common multiple and therefore your lowest common denominator, or you can do a table of multiples. Now, when the numbers are large or far apart, you're probably going to find the factorization to be a more efficient way to do it, because building the table of lowest common multiples can be tedious, particularly if you had more than two fractions to combine. You'd have quite a job on your hand if you try to do the lowest common multiple in table form. All right, so that's one idea. Now, I'm going to slide this down so you can contrast it to the other idea. And the other thing that we're trying to do is we're trying to sometimes simplify a fraction. Simplify a fraction. And what does that mean? It means to, in essence, to cancel out all the common factors except one. And so there are two techniques you can use for that. One way is to build yourself a table of greatest common factors. Now, don't get confused. This one says lowest common multiple. This one says greatest common factors. And so I just said, let's say the fraction is 24 over 36. And I don't want to add these. I'm just trying to simplify this fraction. Well, my greatest common factors is, you say, well, 24 divided by 1 is 24. 24 divided by 2, I'm dividing now. 24 divided by 3, 20, and so forth. So I'm dividing up here. 36 divided by 1, 30, Now, and then what do I do? In this case, I'm going to find the biggest number, right? The biggest number. Oh, down here I found the lowest common multiple. Here I'm going to find the greatest common factor, which in this case is 12. What in the world does that mean? It means that I can simplify 24 over 36 quite easily. Divide by 12, and I get 2/3. Now, if you do a factorization approach, which is the other method, factor these. Here's the same factorization we had a minute ago for 24 and 36, except this time, instead of bringing down the factors the greatest number of times they occur, I bring them down the same number of times they occur. You see the difference there? Here it was the greatest number of times. Here it's the same number, the same. This occurs 2 and 2, 2 and 2. That's it. This one is 2 here, but it doesn't come down. 3 and 3. Only pick up the common factors. And then you put those together, and you get 2, 2, 3. So what were the common factors I pulled down here? 2 times 2 times 3. And so what is that? 12. So this is a more efficient way to do it, but you have to be able to master the factoring. You have to remember how to keep them straight. And I'm either trying to use this with the individual common factors to find the greatest common factor, or in this case, I'm trying to find the smallest common multiple. All right. This is used to add and subtract fractions to find the lowest common denominator. This is used to simplify fractions in the most rapid possible manner. Let me see. Notice, just back up to this for a second. Notice that another common factor that picks up in this chart, and there are some others. Well, here's 4 and 4 and 6 and 6. So let's say that I use 6 rather than 12. Well, I would get what? I'd get 24 divided by 6, which is 4, and 36 divided by 6, which is 6. So then that would be 4 over 6, which can be further simplified. So the point with this greatest common factor business is if you use the greatest common factor in simplifying fractions, you get it simplified faster. All right, so that was a fair amount of work today on fractions. Again, I hope these videos are helping you.